Hello everyone, I hope you're doing well. In this lesson, I will introduce the polynomials topic of year 9 and 10. This topic is very crucial as you will be working with it in your senior years. Even though it might sound a bit scary, it is a very simple idea and a very old idea that you've been doing, just reworded, okay? Now to understand polynomials better, let's just split the word into two, poly and nomials, okay? Have you ever heard of polyester, meaning many materials, or polygon, meaning many angles? You might have guessed that polynomials, like the poly, actually means many. And nomials means terms, okay? Okay, so we can conclude that polynomials actually means many terms, okay? And you've worked with polynomials a lot, okay? From year 8 to 9, you've worked with them a lot. Even year 7, I think. Let me explain. For example, let's say y equals x plus 2. We've always called this linear equations, okay? Even though this is a polynomial, okay? This has two terms, x and 2. That's why we call it binomial, okay? It's a binomial equation. And we call, in terms of polynomials, we call them linear polynomials. Now, let's say another example, y equals x squared plus 4, for example, okay? This is a quadratic. We call it quadratic polynomial, okay? This has three terms, okay? It's still a polynomial. It has many terms, okay? So as you see, it's squared, right? So x, and then 4. So this is still a polynomial. It's x squared. It's x times x, and 4. So 3 terms, and it's a quadratic polynomial because it's a degree of 2. There are lots more, okay? We have y equals, for example, x cubed plus x squared plus x plus 1. This is still a polynomial, except with the highest degree being 3 right there, okay? And we call these ones cubic polynomials. So at this point you've understood that we name these polynomials based on their degree. This one's a degree of 1, this one's a degree of 2, this one's a degree of 3, and so on. It'll be a quartic, and so on. You might ask why. Okay, I'm going to quickly explain to you why we do that. Okay. Imagine f of x equals x to the power of 3. Okay. If we sub in, let's say 10 for x, f of 10 will be 1000, okay? Now let's compare it to another function, okay? Let's say g of x is equal to x to the power of 3 plus 2, okay? Very simple expression. I'm going to zoom out so you can compare them better. Like this, okay, that's good. When we sub in 10, okay, for x, it's gonna be 1000. You might have guessed it, it's 1002, okay? Now if we compare these two, f of x and g of x together, you can see that the change in them is only 2, okay? And you guys know that x just keeps going to the right, okay? So x just keeps increasing for these ones, and the degree is actually what makes the most significant change, okay? No one's gonna care if you're a millionaire if they can just give you like $20, okay? If they give you $20, it's not gonna make a really big difference, okay? This is just 1000, that's just 1002. So we can see that the constant here, the 2, is not making a huge difference. Now I'm going to show you practically what I mean by graphing two polynomials together so you can see why we actually do that again and you can understand me better, okay? Let's compare two very simple quadratic polynomials called parabolas, okay? Y equals x squared and y equals x squared minus 2. These are very simple. You've done that before. And to sketch them, we have to draw a plane. Right, okay. First let's draw x squared, okay? Y equals x squared. It's very simple. You've drawn them before. They look like this. And we have this. Oh. So this is our y equals x squared graph. Now let's draw with blue. Let's draw y equals x squared minus 2, okay? So it goes down by 2, like this, and then it keeps going up, like the other one, like this, and like this. Okay, both of them keep going up, and you can see that they keep getting closer to each other, okay? Now, for this graph we can sub in x equals 10, okay? For x equals 10, let's go back here. We can do it with y. For x equals 10, right? For the y equals x squared graph, when we sub in 10, what do we get? Pretty easy, okay? We get 100 for x. Sorry, for y we get 100. So this is a coordinate when we sub in 10. And for our second polynomial, this one, the y equals x squared minus 2, when we sub in x equals 10, you can guess what we get. We get 100 minus 2 plus 98. Okay, so 10, sorry, I'm going to draw it here. 10, 98. Sorry for the collision. Now you can see that when we keep going up, the difference keeps getting less, okay? So this constant is just shifting it down by 2, but having no effect when it keeps climbing up, okay? So you can see how the degree makes the most impact, okay? Let's just draw one more, okay? Let's just draw one more. Y equals x cubed. It's gonna look like this, okay? We can draw another one, or we can just extend this one. Imagine just keeps like going like this and back down like this. Did you see how just by changing degree by 1 it made such a huge impact? Okay, now if you keep doing this with other degrees, you can see how the degrees make the most difference, and that's why we named them based on the degrees. So there it was, just polynomials, very simple. We're going to be working with polynomials a lot more. We will be dividing them, we'll be using them, and we'll be sketching them, and hopefully you can see that in lesson 2. Right now we just introduced polynomials. Welcome to the Polynomial Club. Thank you.